Hello everyone. In today's session we'll be discussing about load store instructions in ARM. Before you know about load store instructions, we need to know why exactly it is required. ARM has load store architecture. What exactly does this mean? Now let's assume this is your memory, okay? Where each box here, okay, stores some 8-bit data. Any ALU, that is arithmetic or logical operations such as add, sub, compare, or, and, etc., cannot be directly performed on this particular memory location. Okay, instead what should happen is this particular data, whether it is 8-bit, okay, or 16-bit, or let's take a 32-bit data only, it should be copied into some register, okay, and then these operations are performed on this particular register, whose result can then be placed back into the memory. Okay, so obviously since we can't perform these operations directly into the memory and we have to copy it into the register, perform the required operation, and then store the result into the memory, we need two additional instructions. One, to copy the content which is present in the memory to the register, which is called as load instructions, and next instruction to copy the content which is present in the register back into the memory, which is called as store instructions. Okay, when you consider load store instructions, we have three different types. The very first type is single register transfer, then we have multiple register transfer, and lastly we have swap. Okay, let's discuss each of them in detail. Very first thing that we notice here is single register transfer. As the name indicates, these instructions are used for moving single data item in and out of register. But if you say single data item, it could be a 32-bit data, it could be a 16-bit data, or it could even be an 8-bit data. So you will see multiple variations in the instruction based on the data size. Okay, and one more variation you will see is whether you want to copy a signed data or whether you want to copy an unsigned value. Okay, in case of signed data, we are considering both positive and negative numbers. Unsigned means it starts from 0 to all positive numbers. Okay, now let's see each one of them in detail. These are the different mnemonics, okay, for load store single register transfer instructions. The very first one you see is LDR, STR. These are their full forms. Okay, so you already know if it is LDR, it represents loading some data, and if it is STR, it represents storing some data. But we have these variations mainly based on two things. One, data size. One more, whether the data to be copied should be signed or unsigned. Okay, let's start with the initial instructions LDR, STR. If you want to copy 32-bit data, okay, from the memory into the register, then you go with LDR. Okay, if you want to copy 32-bit content from the register into the memory, then you go with STR. So because you know this, I think you can guess here. B here represents byte or 8 bits. Okay, so if you want to load 8-bit data from the memory and then copy it into register, Then you go with LDRB. If you want to copy 8-bit data, okay, from the register into the memory, then you go ahead with STRB, okay. But here you have H, which indicates half word. Half word here represents 16 bits of data. So LDRH here copies 16-bit data from the memory and places the content in the register. And when it comes to store, and here it is H, which again indicates 16-bit data, okay, we are saying copy this 16-bit data which is available in the register into the memory. We have signed concept, and because here it's LDR, we already know the concept here is to move data from memory to register, okay. Because it is B here, it means 8-bit data. Because it is H here, it means 16-bit data. But what is this? Yes, it means that perform sign extension when you are copying content from memory to register. So what exactly does this mean? We will learn it in detail when we will discuss each of this instruction.